One of the applications of AI at the Dutch National Police is the intake agent for online trade fraud. Every year, the Dutch police receives tens of thousands of complaints from citizens who suspect to be victims of online trade fraud. And this concerns, for example, malicious second-hand traders on platforms such as eBay, Marktplaats, or fake web shops that do not deliver. Until recently, citizens had to submit their complaints in a web form, but now they can interact with our intake agent. They submit an initial complaint text, and based on this text, the intake agent gives a well-founded advice. Should they submit their complaint or not? This way, the citizen knows within 1 or 2 minutes whether he or she should submit their complaint. But how does the intake agent produce this advice? We developed an architecture that combines various AI techniques. And this is necessary because the agent needs to meet some important requirements. It should be able to handle natural language, make as few mistakes as possible, be able to explain its advice, and it should be efficient. To comply with these requirements, we combined 3 different AI techniques in our design for the intake agent: symbolic AI, supervised learning, and reinforcement learning. Symbolic AI is based on rules from formal logic. You could regard such a rule-based system as a kind of protocol. Thanks to these rules, you exactly know how the machine reasons. However, you need to design these rules by hand. For supervised learning, no rules need to be made. The idea is that you train a model by giving it many examples, and for each example, you give the right answer. Supervised learning has been particularly successful in classifying multimedia. And the third technique is reinforcement learning. In this type of AI, an agent learns from experience. It executes a sequence of actions and later receives positive or negative feedback. Given this feedback, the agent then needs to reason backward in order to decide which actions are suitable for which situation. So I just told you that supervised learning, or learning based on examples, is good in solving classification problems. Could the intake agent then use supervised learning to classify either the correct advice or a suitable follow-up question? Unfortunately, this is not the case. Machine learning models cannot be used for taking complex decisions because they are so-called black box models. It is not clear how they come to their advice. However, you could use them to classify smaller observations from the text. For example, did the citizen pay for a product? Did he or she wait long enough? This kind of observation classification is done in the information extraction step, the first step in our architecture. As a next step, the intake agent uses its argumentation module to decide if the observations extracted from the text are sufficient to decide if this complaint should be submitted. To decide this, it uses a set of rules. These rules are based on legal texts. And legal texts are typically quite abstract, but in collaboration with domain experts, we made the rules more concrete so that our argumentation module can reason with them. In many cases, the information extracted from the initial complaint does not suffice to give a well-formed advice. And therefore, the intake agent uses the same rules I just described to automatically classify which questions are still relevant to ask to the citizen. Often there are multiple follow-up questions to choose from, but for the sake of efficiency, some questions are better to ask first. In order to decide which questions should be asked next, we use reinforcement learning. Based on earlier similar dialogues between the intake agent and citizens, the agent can derive which question is typically the fastest way to a well-informed situation. And subsequently, the agent asks this particular question. After reading the citizen's response, the intake agent again checks if it has enough information to give an advice. And this way, the citizen receives no more questions than necessary, and the questions are adjusted to his or her specific situation. As soon as the intake agent has obtained sufficient information, the advice is presented to the citizen. And this advice indicates whether or not it is appropriate to submit the complaint, and importantly, it explains this conclusion. So to conclude this lesson, we have seen that the intake agent combines various techniques to meet specific requirements. It interprets text, for example, by applying machine learning for information extraction. Thanks to the use of an augmentation module, the agent can give a transparent advice. By virtue of this transparency, it becomes easier to find and correct eventual mistakes, for example, by adjusting a rule. And finally, the reinforcement learning component optimizes the efficiency of the dialogue.